Hi everyone. Today we're going to be talking about visualizing data. Now, data visualization is a big part of data science. It's how we make sense of our results. It's how we make sense of data sets that we've got a hand of, and it's how we're able to present and tell stories about the work that we've done. And I've got an example on the screen right now of a really nicely designed data visualization from NASA. This one describes all the different times and destinations of the Jet Propulsion Laboratory projects. This is a really visually appealing thing. It can get us caught up in the idea that we want to start designing complex visualizations, or the onus is on us to create complex, really well-designed visualizations as part of what we do. And while no one is ever going to disparage nice data visualizations, I do want to talk about today how the expectation before we talk about elaborate or complex visualizations should be getting some basics right. And these basics are going to serve you no matter what you're visualizing in, whether or not that's Excel, Tableau, or custom stuff that you program yourself, and is also going to kind of keep you rooted in some visualization practices that will serve you, whether you're a data scientist or a social scientist or anything beyond. So let's think about visualizing data as a set of practices rather than a way to just show our results. So there's going to be 4 things that I want to cover today in our really brief video. And I'm going to get into each one individually, but I'll outline them now. The first thing that I want us to think about is that charts do work, and that charts have a footprint, and that looking good isn't the same as being good, and that comparison is important. So let's begin and talk about charts doing work. When I say charts doing work, I mean that 2 things actually. The first is that charts are task dependent. We want to be thinking about what we want a chart to accomplish. Do we want it to show a very specific relationship? Do we want it to be able to validate a certain set of observations? Do we want it to be able to allow us to compare one time frame against another? There's a certain set of tasks that we're asking that chart to accomplish for us. And we're asking that chart, right, when we visualize something. This gets into why visualize anything in the first place. It's so we can see the data. But what data we decide to show and how we decide to see it are important decisions. And those decisions should be related back to this idea of the task. What do you want that chart to ultimately do? If I want to say show a trend over time, right, I can plot time period 1 and the value, time period 2, 3, etc. And I might be able to see a trend over time. Okay. That's going to be slightly different than if I wanted to actually show the location of each of these points and their value, right? In that case, I would maybe make a map. So here is a really horrible map of the state of Arizona. And let's just say I've broken each of these pieces of data down to their location on some of the cities in Arizona. So we might have Phoenix as a bubble here, and then Tucson with a smaller value here. And so, or Flagstaff up here. And so in this example, place is important. And so we're going to encode place-based data into our visualization. Here, time is important. So we have time-based data baked into our visualization. So task matters. And we should be thinking about that when considering what kind of chart do I need. So that's the work of a chart. The other thing that I want you to think about with this first point about charts doing work is that charts externalize pieces of data and relationships and make them visual so that we don't have to hold them in our heads. If I were to rattle off a series of values and ask you to remember them, say, 2, 5, 3, 3.5, and 6, and then ask you to think about those relationships over time, well, that would be very difficult for you to do. And that's only, 5 different values. But in fact, that exact sequence is what we've marked out here. And you can actually see that as a trend. Whereas if you were to just kind of hear them and try to hold them in your head, it would be difficult to think of them as a trend. So you're externalizing work that your brain is doing and putting it on a piece of paper or on a screen. That's the work that charts can do. And so the next thing that I want to talk about is this idea of charts having a footprint. And by footprint, I mean that there is work around charts that has to get done in order to understand them. So one mistake that we can often make when we're showing charts and visualizations is we assume that people are going to understand them way sooner than is actually going to happen. So understanding even a simple chart, right? If I were to say recast the line graph that I made earlier and I draw some points visually, it's also not that great looking of a chart, but visually this is not the most complex chart. But I still have an awful lot of explaining to do. Even if I were to label this as number of blue cars purchased in Phoenix, Arizona, and this was date, calendar day, you might have all kinds of questions about this axis. Like, what counts as a blue car? Is it cars or trucks? You might ask of this, where did I get my data day by day? Did I get it from car dealerships, used car dealerships? Did I get it from cars.com or autotrader.com or some other website? So there's all kinds of questions attendant to understanding completely a data visualization and allowing it to do that work that's important to us. So that footprint is an explanatory footprint. And it shouldn't be a surprise that that exists, right? All charts have some kind of context. And because they're representing data, data has context. And so we should expect to communicate that context whenever we're thinking through charts. And sometimes for you, if you're busy making charts for yourself, it's very easy to know what a chart means right away, but always consider your audience, and you'll help to appreciate what that footprint means and how to explain that to someone who's encountering your chart for the first time. All right, let's go to this third point. Looking good isn't always being good. I think sometimes we can get at cross purposes when it comes to statistical data visualizations about what a good chart is. And I think, good is one of those relative terms. For our purposes today, we're thinking about clarity and how well it accomplishes. That's point one, right? Is that chart able to do the work that we have in mind for it? And so we want to avoid using things like color or clip art. Well, I don't think it's a controversial opinion at this point to say that you should probably keep clip art out of your data visualizations. But when it comes to using other things like color or other kinds of ornament, be careful that your color is actually encoding or registering some kind of differences in your data, and that color is there for a reason. A lot of times, especially with the use of different kinds of colors and color scales, we might be able to roll out a really beautiful looking graphic that uses all different kinds of colors, so we can try for an example here where I've got this as one color and my next point is another color. And I've successfully been able to make something that is kind of interesting looking because I've used color. And this kind of extends to lots of different things, but this looks interesting, but it isn't adding any additional data or understanding. In fact, it might be taking away. And so sometimes if I'm making a chart, then merely having it be at a different date is enough to set it off as a different thing. We don't need color to set it apart. And so whether it's clip art or using too many different kinds of colors or lines to be able to set things apart that have other ways of setting them apart, right? And our example here was this day is already considered this day because it's oriented on an axis. We don't need to change the color of it to help our audience understand. Likewise, if I were to create some bar charts, I wouldn't necessarily need a different color every time I had a different category of values because they're already labeled as a different category of values. And so let's get into this for just a second because I want to make a quick point. So if I were to make a bar chart, say I have a bar of values here, and then on the next category, a bar of values here, and then a bar of values here. This, again, not the best chart in the world, but here we are, we have our axes, and here's our bars. We don't need to color code each one of these a different color. That's not going to help us because they're already distinct. What could help us is if for some reason we decide to add additional values here. And now I actually need help being able to visually delineate between the two different things we're measuring at a given point in time. And so think about the appearance of the chart, and that the appearance of the chart is supposed to serve some kind of function, and that we want to make sure that whatever visual aspects of it that we're putting together aren't redundant with something that's already intrinsic to the chart. Okay, and let's move on quickly to the very last one. And it has everything to do with what we've been talking about for the last 3 points, and that's comparison, right? We want to compare, compare. A nice litmus test for understanding, is your chart doing anything? Asking yourself, what is this chart allowing you to compare? What comparisons is it facilitating? So visually, if we're looking at a chart, being able to compare different values can be a big help. And so we want to be able to stage as many different comparisons as possible. And that should be the logic of our chart. So if I'm drawing a chart here, that is going to have a bunch of different layers on top of it. So we'll just add to the chart that we just drew of a bunch of different bar graphs with different colored bars. And I want to have some buttons over here on the side. And anytime you click a button, then I can layer on, even more data. I can add a trend line out over here from a different data set, and I can layer on a map in the background if I want to. I'll just put all kinds of layers of data on there, right? And this is a little bit of a ridiculous case, but we can see other kinds of examples of that, say and I'll draw here a map of Arizona where we might have all different kinds of layers of data. We might have national forest land that you can click on, and then that's shaded in green. And then we might have another thing about, average number of visitors per day on these national forest land, and that's going to be a bubble chart, that's going to be a layer. And then we might add on other kinds of economic revenue data. We're just going to add all kinds of layers onto this chart, but we need not think of everything as a layer. We need not think about putting everything together. Another kind of simple example that we see all the time of this kind of thinking around a chart is that I'm going to have a line graph and I'm going to plot one trend, and then I have 5 more trends or maybe 15 more trends that I really want to plot. And so I'm just going to put all the lines on top of each other. And so I'll just draw them here as being layered and squiggled on top of each other. And you can see as I'm illustrating that the more trends we add, the harder it is to tell the differences in trends. And so this is an approach that, while we could be using color effectively, we could be making sure we have a good footprint, we could have the best intentions about this chart externalizing certain thought processes so we can better sort through our data by making it visual, it doesn't really help us compare, because there's too much stuff layered on top of one another to allow us to really make a good comparison. If we were to take every single one of these lines plotted and separate them out, so that instead, and I'll just draw above it an alternative, we could just have each trend plotted separately with the axes normalized. And that allows us to compare much better than we could if those trends were sandwiched all on top of one another. So that's an improvement that doesn't require a whole lot of additional design. It doesn't require a bunch of different color. It doesn't require us to make something that's very complex. It just asks us to make comparison the essence of what it is that we're doing. And so those are the 4 points that I wanted to talk with you today. It's important to think about these as a guide to thinking through how you can make visualization not this big, elaborate thing that you do at the end of your work, but as simple things that you can do that are guided by principles for making sense of your data. And they're things that you can do every day and all the time. So thank you for joining us for this video, and we'll see you in the next one.